scientists, a mixture is a combination of different substances. So, a mixture is not chemically pure. It consists of different substances such as, for example, take minerals. Minerals consist of different types of minerals, right? And at the same time, every natural substance like milk, ghee, everything what will be obtaining, curd, all these substances are not chemically pure because they are mixture of some chemical components. Therefore, different types of methods we will be using to separate the mixtures, and the major methods or day by day or daily methods what we use to separate the mixture is hand picking, sieving and filtration. The filtration process we will see generally in our day-to-day life, that if we prepare coffee, we will be filtering the coffee powder by using the filter, right? At the same time we will be using sieving, and at the same time hand picking, like we will pick up with the hand the stones in the rice. That is a good example. Like this we will be filtering some substances from other substances, right? And these are the day-to-day life filtration process or separation process we will be using in our mixtures. And now let us see what type of mixtures can be separated. That is only heterogeneous mixtures. Only heterogeneous mixtures can be separated into their respective constituents by single physical methods, because heterogeneous mixtures are formed by different types of substances and having different chemical properties. Therefore, we can separate them because the particles will be settling down, so we can separate them easily. Thus, these types of separations are done in order to separate the substances and to get the pure forms of substances from a mixture. Now, let us see how can we obtain a colored component dye from blue-black ink. See how we will be getting blue ink and black ink and red ink in pens. Let us see that. Now let us see how to separate the dye or black or blue ink from an ink motif. That is, let us see one activity. Now fill half a beaker with water. Say take a beaker and fill it half with of water. And second step is put a watch glass on the mouth of the beaker. That means place a watch glass on the mouth of the beaker, because why we are taking watch glass means in order to see what are the changes happening in the beaker. So third step we will be taking, put few drops of ink on the watch glass. Now we will be placing 3 droplets of ink on the watch glass. And let us say fourth point, that is now start heating the beaker. We do not want to heat the ink directly. That means what I mean to say is we are heating the water beaker, that is the container with water, directly with the help of burner. But we are not directly heating the ink what is in the watch glass. So we will be seeing the changes what are happening in that. That is when we go on heating the water, due to the heat radiations or vapors of water will heat the watch glass and the ink will be formed into vapors. That is, continue heating as evaporation goes on. Stop heating when we do not see further any change on watch glass. That means we do not want to heat the ink directly, right? When we heat on the water, the vapors will be going off, the ink vapors, right? The ink vapors will be going on because of evaporation process. Thereby, we will be seeing some residue forming on the watch glass. After a certain period of time, there will be no change on the watch glass. So, we will be stopping the activity thereby, and we will be recording the observations or what we have seen in the activity. That is, first thing what we will be noting down is it is done through the evaporation process. Here we are not directly heating the ink. And now the remaining part or the solvent we will be evaporated. The solvent is evaporated in the ink by the process of evaporation, and the solute particles, that is dye or blue color or black color of ink, will be remaining in the watch glass. By this we can separate the black color or blue color dye from an ink. And this can be done by yourself and see, note down observations and let us see how to separate those mixtures. The filtration process is a daily process what we will be seeing in our day-to-day life, but actually the small particles or small substances will be coming through the filtration also. Therefore, we will not be going to filtration process for very small particles of solutes. So we will be going to centrifugation process. This process is done in order to separate imperfectly, in order to separate perfectly and make a pure substances from the mixture. Therefore, the centrifugation process is used in order to have, that is the definition hereby goes like that. The principle is denser particles are forced to bottom and lighter particles stay at top when spun rapidly. That means the denser particles means the particles having heavy weight or having more density than water are forced to be settled down in the water or solvent, and the lighter particles are made to be or pushed up to the top surface of the solvent. By using the spun system, it will be a very speed system or machine used to rotate the solvent very fastly, and thus the levelation of particles is done. This process is known as centrifugation process, and by this we can separate the lighter particles in one way and the heavier particles in one form, and thus we can separate every substance as pure as possible. And let us see the applications where we will be using this centrifugation process. In our daily life, we will be seeing the washing machines, right? In washing machines, mainly we will be using the centrifugation process. That is because the centrifugation process means the outward force is used to collect and it is used to separate the mixtures. That means the clothes in the machine are wet. It will be absorbed with water, right? Therefore, they will be separated, or the water in the clothes, wet clothes, is squeezed off by using the centrifugal process. That is, we will be using in washing machines to squeeze out water from wet clothes. And another application is used in dairies and home to separate butter from cream or cream from milk, and also in diagnostic laboratories for blood and urine tests. We will be having blood, right? In the blood we will be having little chromosomes, microsomes, and which are not visible to our naked eye. They will be easily separated through the centrifugation process. Now let us see how to separate a mixture of two immiscible liquids. Immiscible means having the liquids or having the substances of different densities. The densities of two substances or two liquids will be different. Now let us see with an activity to learn how to separate the immiscible liquids. Let us try to separate kerosene oil from water using a separating funnel. Let us take a separating funnel and fill it with both kerosene oil and water. Now let us pour the mixture of kerosene and water without disturbing. We have to keep it for some time, and let us see. We will be observing some layers are formed up. That is, a kerosene layer is formed up and water layer is formed up. That is, water with having more density will be settled down, and whereas the kerosene oil with lesser density will be moving on the surface of water. Now let us fix the separating funnel with the help of a stopcock at the bottom of the separating funnel. Now when we open the stopcock, we will get first the water which are having higher density, which are settling down in the separating funnel. Now the water will be flowing out from the stopcock, and now we will be closing the stopcock when the water is completely gone out from the funnel. And then we will be stopping the stopcock here, and we will be closing the funnel right now, and we will be getting only kerosene oil. Thus we will be separating those two by the process of filtration. And this process is done only for the liquids having different densities only. Now let us see the observations what we have done. That oil reaches the stopcock and we will be closing it off, and those applications are separating the oil from water, or separating the iron from ore, and separating some minerals from the mineral ore. These are the all applications we will be using for separation of immiscible liquids.